Hey guys, it's JM. Today I'm going to make a video about hard drives and how they fail. So, as many of you guys know, hard drives have moving parts and they are subject to mechanical failure. Hard drive is made up of disk platters, and a mainstream hard drive today, like the 16 and 18 terabyte hard drives, have actually 9 disk platters on them. And then they have an actuator that the heads are mounted on, and the heads go back and forth. And that head actually is reading data on these platters. And on a 9 disk hard drive, like a drive that's an 18 terabyte drive, there's actually 18 heads. And so there's a lot of places where things can get broken. And so this is very, very tiny. You're talking about ones of nanometers of distance between the head and the platters when it's doing writes, for instance. So these have to be very, very precise. And when you use a hard drive for a very long time, and you do these, like if the head is loading and unloading, or if you're doing workloads where the heads are moving around a lot, eventually after many, many years, there's tiny particles that get released into the drive, and those drives can bump into the heads, uh, and they can cause disk errors. And you'll see the easiest way to basically find out if a hard drive is bad is to look at the smart data. There's all kinds of valuable smart data that the drive provides that will tell you basically if the drive is failing and the statistics of the drive. So I'm going to walk through a little bit today on just how to read the smart data on a hard drive, how to tell if a hard drive is good. Chia is very interesting in that Chia farming does not use any user data. It's all just random plot files. And because of this, you don't really need any data protection, so people don't use RAID or erasure code or backup in Chia, because if you have a drive failure, you can just replot and make some new plots and fill it back up. And now, something even more interesting is that you can use kind of old drives in Chia farming, and they do fine because Chia is a very light workload. Once you totally plot the drive and you're doing some reads on the drive, plotting every 30 to 60 seconds, if you're on a big drive, you're going to be doing a couple IOs. It's about zero point 0.6 IOPS is the actual workload, which is input output operations per second. So it's a very, very light workload on the drive. So even if you have uncorrectable errors in the drive, you may read them for years in farming and not hit them. Each one k equals 32 plot file has like 4.3 billion proofs in it. So even if you had one uncorrectable error, if it was in table one, you might have some messed up proofs, but it's really not going to just be catastrophic for Chia farming. So Chia is a really awesome, interesting workload for used drives. And so, knowing how to look at smart data on drives, especially when you're buying these things from Craigslist or eBay or whatnot, is super helpful. And also, just if you're buying a new drive and you're starting to see smart failures, then knowing when to return the drive or what's causing them. So, I have my little desktop up here. Okay, so I'm going to do a quick demonstration of smartctl or smartmontools on my Ubuntu system. This is just my home desktop farmer. It's an i5 system with 10 hard drives attached to it. They're all locally attached through SATA drive, the SATA bus, and then I have, I think, an HBA with 4 drives connected. It's a LSI 9200. So it's just a small system that I use for messing around for testing home. So the first thing you do is sudo apt install smartmontools. I already have it installed, so it's just going to tell me it's already installed. That's great. And you can do a sudo smartctl-scan, and this is just going to scan all the devices in your system. So this will tell you all the drives that are attached. This should match the output of LSblock or fdisk or anything else you're using to look at all the drives in the system. So the next thing we're going to do is actually take a look at these drives. So we're going to do sudo smartctl-a. -a is -all. There's also a -x, which reads the logs. We'll look at that here in a second. But so for -a, here we go. This is, let's see, this is a WD-HC550, 18 terabyte drive. So it'll tell you a little bit of information about the drive up here. And it will tell you some general smart information, but this is really the stuff that we're going to look at. There's, the smart table was where the attributes we're going to look at. And this is really the bread and butter of when you're looking at smart. This is kind of the table where you spend the most time on. And I'll do some more advanced stuff at the end of the video of how to monitor this stuff in the background, so you can just kind of collect the smart logs over time, because it's very, very interesting to look at the smart logs and smart health information of a drive over an extended period of time, because then you get a kind of feel for what's happening on the device. So the first thing is a raw read error rate, and generally these don't increment. It's uncommon to see anything besides 0 here. That could be an indication of a weird drive issue, like some kind of vibration issue, if this is a non-zero value. But in general, this is just going to be a 0. This is just your raw read error rate if you are seeing weird stuff on the drive. Throughput performance is just like a normalized version of like how much throughput is expected on the drive. Spin up time. This is how long it takes to spin up the drive. Start stop count. Now this is going to match your power cycle count. So 20. In this case, we have 20 power ups on this drive, but those aren't prefill. So you can see the ones that say prefill are ones that are going to do, if they are above the threshold, they'll trigger a smart predictive fail, and then the software and operating system, or if you're on a host bus adapter, will start flagging these drives as bad if you have a smart predictive fail. And sometimes, now if you're savvy, you can look at these attributes and kind of figure out before it fails and before it even has a pre-fail on it, like when your drives are going bad. So one of these is, seek error rate was kind of interesting. So this is one where a lot of people are doing DIY stuff where they're mounting drives, to custom enclosures or pieces of metal. They're doing cheap stuff. People are putting them in wood. I've seen all kinds of interesting stuff on Reddit and Twitter of people doing DIY Chia stuff. And if you are seeing, so I mentioned, drives have moving parts and they are subject to rotational vibration. If there's outside, if drives are right next to each other, then the rotation and vibration of one drive can affect the other. And that's why in chassis you have, drives that are mounted to these carriers, into these backplanes that kind of protect against that. And they have some protection from this rotation. But if you are seeing a seek error rate that is high, this may be an indication that you have not properly mounted the drive. And it's an interesting thing to look at. Now, we're going to spend the most time on this reallocated sectors and current pending sectors. These are some of the most important smart attributes that there are. So when a hard drive when there is a particle or something in the drive and it has an actual physical corruption on the disk, it will reallocate that sector, and the firmware is smart enough to say, okay, well, this data was here, let's try to put that somewhere else. And what the drive does is actually reallocates that sector into somewhere else on the drive that's not broken. And so reallocated sector count is something that is very indicative of a hard drive failure. So what happens is when you have a LBA that is corrupted and the drive needs to reallocate the sector, it'll actually put it in this current pending sector. And then once that LBA is written to, then it will move it to a reallocated sector count. So it'll basically be sitting here in pending, or this 197 current pending sector, until you write to that data, and then it will get moved to reallocated sector count. So if you see either 197 or number 5 incrementing, that is bad. That means that there's something, it may not be catastrophic, or if you just see us, 1 or 2 here, or 5, and it's just staying there. Okay, maybe that was some kind of weird event, and that maybe it was a one-time event. But if you see these attributes incrementing over time, and you're looking at this drive over a period of months or something, and that number keeps going up, that is indication that your drive is failing and you need to replace it. So power on hours. So generally, most drives are rated for 3 or 5 year warranty, and so drives. It's not just how long the drive has been on. That's certainly one useful metric, right? And that's one, if you're looking at a drive on eBay or Craigslist, generally they'll list the power on hours because it's like an indication of how long the drive's been used. But I mentioned with the hard drives with the moving parts, it's not just a function of how long it's been on, but it's also a function of what the workload was, what temperature the environment was, what humidity the drive was at, what rotational vibration did the drive see. So you can see all these variables affect the drive. It's not just just power on hours. So, but it is a good metric, right? If you have some drive that has an absurdly high number of power on hours, like that's maybe not the best drive to buy. Or if you do see a drive with super high power on hours, make sure you're getting it for a very good price. Power cycles count I mentioned is just how many times the drive's been powered on or off. Now the interesting thing is 192 and 193, and they, these might be slightly different numbers on different drive models. And we can poke at another drive here a little bit and make sure. But this is just load cycle count or power off retract count. This is how many times the heads, when they're not being used, actually get parked, and this saves a little bit of power on a drive when with these 18 heads. If they're all not being used and they're all parked, it saves about 2 watts of power. Now in the Chia workload, you're getting I/O requests, even though it's not a very heavy workload. You're only doing a few reads every 30 seconds or so for each drive. Well, that's not long enough for those quite to go to sleep, because it takes a few 100 milliseconds, I believe, for those to get unparked, and it takes some energy to do that. So it's not generally so one is, if you did that every 30 seconds, you'd wear out the drive prematurely, because each drive, I think this drive is rated for about 600,000 lifetime load unloads. So if you did that, if you parked the heads every 30 seconds for 5 years, then you kind of be over that limit. So and NAS drives have different kind of firmware tuning for this what they call idle timer, idle B timer, when the drive goes to sleep. But you basically know if this number is like some absurdly high number and it's a brand new drive, then your drive is aggressively trying to go to sleep too much. Right? There's some weird power state thing that is going on there. So just something to monitor. Temperature Celsius. So this is very important. As many people know, one of the things I'm not crazy about in smartd, which is the background operation for smart control, you'll see I'm not crazy about it, that it reports the smart in temperature in normalized values, like 0 to 100. It should just report the temperature Celsius. Drives are rated generally for 60C, and the general practice is the cooler you run the drives, the better for the longevity of the hard drive. So if you can run the drive between 25 and 30C, that's great. Even 30 to 40C is okay. If you're running the drive close to the limit at 50 to 60C, that's when there starts to be concerning, because you will have accelerated wear out of some of the components running it at a much higher temperature. Now, they won't tell you that. Hard drive manufacturers rate their drives. A typical enterprise drive is rated for 2 million hours mean time between failure. That's the same thing of basically saying 0.44% annual failure rate. Those two are exactly the same thing. That just means when you expect 2 million drive hours, so it's not just saying you can run this single drive for 2 million hours, but you're saying if I run a collection of drives and I run all those drives and add up all the power on hours, if I run all those for 2 million hours, on average, I'd expect 1 failure. So that's how you measure hard drive failure. And this is called reliability in the hard drive world. But yeah, generally, and they'll tell you, okay, if you run it up to the limit, you can meet your rated MTBF. But basically, if you run the temperature lower, it is better for the drive. So make sure you have adequate cooling for the drive, and that's very important. Okay, so we mentioned this reallocated event count. That actually increments when you have a bunch of pending sectors that once they're all written to, maybe that all happens at once, then they'll all get moved from a current pending sector to a reallocated sector. And so this is just a nice way of kind of looking at what's going on the drive. Now, an offline uncorrectable. So an uncorrectable error is, so hard drives are generally rated at an uncorrectable bit error rate, and we call this Uber, UBER, uncorrectable bit error rate, at 10 to the minus 14 or 10 to the minus 15, depending on the model. Now, SSDs are generally 10 to the minus 16 or 10 to the minus 17 for uncorrectable bit error rate. That just means if you read that many bits, on average, you expect 1 bit of data to actually read that data and just say, we cannot read the data. The host and then gets data that, and the drive basically says, we have no idea if this is good or bad, sorry. And that's called an uncorrectable error. And these are pretty rare. And now in storage systems, basically there's RAID and erasure code and all kinds of backup to make sure that when this does happen, it's not catastrophic. You can just rebuild the data from somewhere else. In Chia, if this happens, again, it's not terrible, because you might corrupt a couple plots, or a couple proofs within one plot, and generally this wouldn't even mark a file bad unless it was in the file metadata. And so it's not terrible, but in a regular drive, any uncorrectables is bad, right? If you're running a database or you're running, bank software, and you want to know what your bank account balance is, like having a bit of data is corrupted, it's not good. You don't ever want to give the host bad data. So an uncorrectable is just telling the host we don't know what the data is. So it's not silent data corruption. It's just saying we don't know. Now an offline uncorrectable is basically if the drive does some scrubbing in the background. So the drive does some read patrols and scrubbing in the background. If it finds an LBA that it can't read, it will report it here. And then the UDMA CRC error count. A CRC error is something on the bus, which means if you have a CRC error, this would be indicative of like a backplane issue or a cable issue or some kind of connection issue or just some kind of signal integrity issue. So SATA is pretty easy as far as like signal integrity goes in high-speed signals compared to like modern high-speed signal design. You can see my books in the background here. One of those is called High-Speed Signal Design, which I used to do. So yeah, SATA at 6 gigabits per second is not too hard. So generally, I would be highly concerned you have some kind of weird system issue if you are seeing these. But okay, so that's the smartctl-A. Now the other thing you can do is if we do a smartctl-X, this will give us the extended logs. And so this will give us all kinds of interesting stuff. There's a general purpose log, which gives us a ton of information here. Actually, this is the SET temperature history version. So this actually tells us the index, the time, and what the temperature of the drive was. The drive actually records the temperature on the drive for a certain number of increments. Device statistics log. So this is one of the general purpose logs in SATA. And so this will give us a lot of the information that was in the smart log. Lifetime power on resets, power on hours, logical sectors written, number of write commands, number of read commands, spindle motor power on hours, head flying hours. So this is awesome. My spindle motor power on hours and head flying hours are like identical, which means this, my drive like has not gone to sleep very often. Head load of heads, 406 is like very, very few for this number. So here you go. So there's all kinds of temperature logs. And if there are some other different kind of errors, you can see them in this log. But generally, you won't have to poke around in this stuff unless you're like really, really going deep. And then if there's a SATA, the SATA PHY error counters, this general purpose log OX11. This is like if you're seeing SATA PHY issues, you might want to be able to look at some of these to find out if is it the host, is it the drive, are you seeing CRC errors? You can see here, we had 3 events here: device to host register, FIS is sent due to a COM reset. And that just means the drive, the actual SATA bus, reset the drive 3 times over the whatever lifetime of this drive. I've been running it for a couple hundred days, so that's not bad at all. That's it. So this is what the Smart looks like on a fully functional drive. At some point I can grab one of these really crappy old drives that I have, throw them in here and do a follow-up video of like, I do actually have some pretty beat up drives that I bought on Craigslist that are still farming just fine. And I did look at the smart data on one of them and I was just like, oh wow, lots of reallocated sectors, lots of uncorrectables. And, I didn't see a ton of errors in the kernel or file system level as far as Chia throwing errors or getting uncorrectables in dmessage or anything like that. So which indicates to me that Chia's a pretty light workload, and even a drive that has a decent amount of errors can farm pretty easily. So that's basically the phase 1 of this video. The second part is within Smart, there's a thing called smartd. It just comes packaged with smartctl. And if you look in, I believe it's in /var. Let me see. I have some notes here. /var/lib/smartmontools. This is where it actually keeps a CSV and state of all the logs, and it tracks this in real time. And if you do a journal control, and you can do a we'll just say since 1 day ago and grep smart, we'll see all the smart events that happened. You can see temperature Celsius changed from 33 to 32, 59 to 60. So these are actually the normalized values. These you can actually change it if you want to report in Celsius. These are the normalized, 0 to 100, which I think is kind of stupid, but I haven't messed with it as much yet. And so by default, the smartd does a smart log dump every 30 minutes. That's bad. Let me show you where, if you edit the, I think it's slash, let's see, /smartd.conf. Oops, cat. We want to cat that. This will show us the actual document. Now, you only have one line in here that actually matters, and this is the one that we're looking at. I edited this just a very tiny bit, and I'll show you what I did. I changed it to DEVICESCAN and then a -a, which basically just means, hey, dump the health information and the error information to these CSV logs, and then do it on the whatever schedule is set to default. And I'll show you how to change that in 1 second. But if you uncomment this line and change that, this is really useful, because then it basically dumps all the smart attributes to the CSV, and you'll have a history of all these drive smart attributes. You can look at if you have a drive that's bad, you can say, okay, when did it start going bad? Like what was going on in that drive, like when it broke, and you can kind of go back in time and look through it. And so this is really useful data to have on the course of your drive. Now, the default is every 30 minutes, which I think is kind of insane. You know, you really need to look at this stuff like once a day. I think it's perfectly fine. And so after you change this, now you can alternatively you can have the smartd actually go in and do a self-test. There's a short or long self-test, and you can have it do that like on any regular basis. I think you can see here, there's some examples of basically how to perform a self-test on like a given date. I'm not crazy about this, and I'll tell you a little bit why here in a sec. So I'm gonna basically clear this. So smart self-test is useful. There's a short self-test, which is 2 minutes. It basically just does a quick test. And if your drive fails a short self-test, then it's really broken, because you can't do a lot of testing in 2 minutes. But you can run a short self-test, and then if you do a smartctl, -a, in the self-test, it will basically tell you no self-test in the log. So I haven't ran a self-test here, but if I want to run a test on this drive, it'll run a test, and then it'll report the output in the smart log and say, is this drive good or bad? Okay, so that's a pretty useful thing to do, but as you saw, it's a lot more useful to actually understand the smart attributes. The other thing you can do is a long self-test, and that's the extended self-test. And that is actually interesting. If you buy a brand new drive, you could just write all the LBAs, like just do write zeros for the entire LBA span, and then you'll find any uncorrectables, you'll find any reallocated sectors. The other thing you can do is basically run an extended self-test. Now, extended self-test will do a full read. It's not destructive to the data. It should just do a full read of all the LBAs, and if you have any uncorrectable errors, it will report them. So they're useful, but only to a certain point. So remember, so if you want to edit the smartd.conf, you can do that, and then you can change what kind of stuff the smartd logs. By default, it doesn't log all the devices, I don't believe. I think you have to change it. And then you can look at the journal control to kind of look for smart events. It also is in, I believe, it'll write the basically the CSVs and the state to a attribute in /var/live/smartmontools. And if we look at this and we can show you this cat one of these. It's just going to be this CSV data. Now, if you look at this, it's kind of messy, but you can see this is the actual attribute number, and this will match that exact smartctl-a that I showed you before. That's the smart attribute number, and then this is like the normalized value. So yeah, and then the timestamp for all of them. So if you wanted to graph all this stuff, you could look at the CSVs there. And then the last thing I'm going to say is, by default, if you go into let me do this here. If you look at this file, which is the defaults /etc/default/smartmontools, you'll see smartd, ops, and the interval. And so by default, this is on a 30-minute interval. I mentioned I just changed it to 1 day because thrashing the drives with a bunch of smart commands every 30 minutes is actually way too much to be reading. So you don't need to do that. 1 day is perfectly fine. Okay, so that's smartd. And the last thing I wanted to show you was, and I'm going to do this in a screen. scrutiny. Okay. So there is a basically a tool called scrutiny. And let me see if I can pull this up here. Okay, so this is really cool. This was actually written a while ago, and I can't remember. I actually don't know the developer. It looks like the developer's name is Analog J. But this is pretty slick. It basically is a web-based tool for reading smart on drives. And alternatively, you can dump the data to a database if you wanted to put it in Grafana or something else, which I think is useful. But it runs in Docker, and it's pretty slick. It's very, very easy to run. So you basically just copy this Docker code if you have Docker enabled, and you basically just put all your devices in here, and it runs. So I'm going to show you here. If I have scrutiny. So what I have here is just all the devices, the 10 hard drives in my system. I put them in here, and so I'm just going to run this sh scrutiny.sh, and it's just going to run this little Docker here, and it's really slick. So what this does is it just goes and runs. You can see it's basically just running a smartcontrol-x/-j, which is JSON, and for every device, and dumping it into a database. And then it basically has, in the Docker, it has a little web UI for running all the smart of the drive. So you can see exactly the smart information that I had in my drive file from Smart Control. I can see here as well. And you can basically click on the drives. Now, I can't vouch for all how accurate this is, but it appears from me just poking around at it that it is identical to the smart information that's being dumped in Smart. You can see it, that makes sense because they're just using Smart Control to do this, and what they're doing is pretty interesting. So there's I mentioned that Backblaze study before, which they highlighted some of these attributes that were indicative of prefill, which I agree with. I talked to folks at Western Digital, and I talked to Seagate, and they agreed that those are reasonable things to look for hard drives when they fail. But these are these ones highlighted in yellow. So like we talked about reallocated sector count. We didn't talk about spin retry count, but we talked about the seek errors and the seek performance being kind of interesting. But you can see here they have reallocation event count, current pending sector count. Let me pull this up a little bit. So current pending sector count. So this is pretty slick. You can see all the drives. If I go back to my dashboard, I can see all the drives in my system, and it gives me a little summary of the temperature, capacity, power on hours, and the last smart log if it passed, and then the serial numbers and whatnot. So I don't know if he is doing any more development on there, but it might be a good opportunity for the Chia community to step in and help out this little project, or take some of the goodness and build it into one of the Chia dashboards. I think this is really super important information. If you're looking at a dashboard for Chia, you probably want to know, like, if your hard drives are good or bad, and monitor that stuff. So, okay, that was hopefully a decent little deep dive on Smart. And if you guys like this, we can go even deeper and take a look at some of my old hard drives. And even there's a slightly different process for SAS drives. If you have SAS drives instead of a SATA drive, you can still run Smart Control. It's just gives you a little bit different output. So maybe that's for a future video. But all right, thanks again, guys. Bye bye.